Hi friends, today I'm back again, and this time I'm going to tell you about deep learning. I guess you most of the people heard about it. Okay, that's an extension of neural network. And what I'm going to show you today, I'm going to show you an application of deep learning on handwritten character recognition. Okay, this is an application which is uh, on build-in stage. Okay, and everything is under process. Okay, every company, most of the companies working on it, how to develop an application which would able to create the document from a handwritten character. Okay, so before proceeding, let me tell about myself. This is Ajay Jatav. Okay, and I belong from an organization which provide the research solution all across the world for any query related to this code and research organization. You can call me. You can get this code by calling me and mail me at very low cost. Okay, for further assistance in technical paper writing. Okay, so I belong from world most reputed organization who promote the research and development by helping various scholars and scientists related to understand the importance of mathematics and mathematic tool like Matlab, Python, etc. Okay, we have also help companies to develop their machine learning algorithm. This is my number. Okay, friends, let me tell you one thing very clearly. And the services are everything is paid. Okay, the only thing you get the tutorial free on YouTube. For rest of the thing, you just visit our website, mail me your query, and you can contact us. You can also learn about the technology, about the programming. Okay, at mindcreature.com. That's our online training platform. Okay, so here I go without wasting much time of yours. Let me show you the implementation, how it works first, and thereafter I will tell you how I build it. So I hadn't changed the graphical user interface. Let me change it first. Deep learning. I don't like this color anymore, so I just put my favorite color on it. Okay. I don't like this thing as well, so I just putting the favorite color of it. Put one of the thing. How do I left this thing? Okay, now it looks better. I'm not using the gradient technique and anything like that, so I'm just make it black. Yeah, train button, test button, access, number of input image, access, upload. Mhm. I'm just changing the color as well. Okay, now let me save this thing. So here I go. So this is something I'm going to show you how it works. Okay, my friends. So first you require a handwritten text document. I obtained this text document from Google. So this is our text document. Okay, life is one long process of getting tired. Is it true? Yeah, I guess so. So here I start the training. Here you can see first phase of training start from autoencoder. Here I gave the 108 input layer. Here encoder is having one, it's, yeah, that's a second phase, that's a third phase. Okay, it's going on everything very fast. So most of the person who have little bit knowledge about the neural network, most of the time he often see the single layer neural network. Here you got the input, here's the output, and the one of the softmax layer or something like we can use the neural network feed forward, cascaded forward, and whatsoever it is. So one of the layer you see most of the time, but here you can say, you can see the let me start, let me yeah, let me take the screen draw section. Okay, let me choose the pen. Okay, so you can see, okay, single layer neural network, previous one. Okay, let me add the text, add marker. So previous one, and in the modern neural network you can see there are three neural network. I'm very pathetic in drawing, my friends, so ignore it. So okay, what deep learning means? Deep learning means instead of training corresponding to your features, what's your feature is? Stop drawing. Select tool. I don't know how to stop it. Okay. So you can see there's a multiple time of training has been happen in case of deep learning. That's the concept of deep learning. You do multiple training instead of single time training. You what you do? You extract the features from your features and thereafter do train your neural network. Thereafter again extract the feature, then from the feature, and meanwhile you again do the training. That's what happened in case of deep learning. And the final learn matrix looks like this. Here you have 58 input layer. That means 58 features. One the the neural network over which you perform the training, and the output layer. Okay. So let me test. Let me check whether our deep learning neural network would able to um, estimate the text and will be able, whether it is able to convert it from the document. Here you can see there's no output docs available. Yeah, there's output docs available, but I'm going to delete these things as well. So what I did, so here no output.txt file is available. Now I'm going to extract the text and let me see whether our algorithm would able to detect the text or not. So this is our input image. Live is one long process and it is being tired. You can see it categorized 9 character and it's sequentially giving the output. ES. Then on third line it is 40 character, and here you can see the character is segmented. And let's see what they have written. So here you can see. Oh yeah. So that's a long process, my friend. And you can see it is able to categorize each word clearly. So what I'm going to show, my purpose is not to show you the application of handwritten character recognition. That's an application though, but my task is how it happens, how you would be able to train your neural network, and how you apply the deep learning over some features. Okay, so here we go. So what I did, I'm just open a program, train features. Okay, these are my features. As you can see, I created these features with the help of these vectors. Let me show you these vectors. Yeah, you can see I've taken the multiple sample of handwritten characters. They start from A1 till A25. That means what I do, I obtain 25 different type of handwritten characters of each alphabet. Okay, here I created the dataset. It takes long time to create a dataset, buddy. That's a very lengthy process. So what I do, I after with the help of these dataset, what I did, I extracted the features, and the features is look like this. Let me open this folder. That's our input matrix. Let me paste it, and you can see these are the letters. Each row in this matrix represent a letter. And how many features I have taken? I have taken 108 features. And how many character do I have? I have 650 character. Okay, 650. You can see here. Hmm. The 650 character. You can see. Okay, the 650 character. How do you calculate these 650 character? Let me show you. CLC. As I have already shown you the data set, I guess these are the data set. And each for particular alphabet, what I did, I taken 25 samples. Okay. So how many characters totally we have? 26. 26 multiplied by 25. That is equal to 650. Okay. And how many features of each character do I taken? I had taken 108 features. Okay. This is also mentioned here. Okay. What does it mean? Everybody is thinking, what does it mean? How it is recognized? How what exactly it is meaning? Okay. So let me give you a briefing. This is our train feature. Okay. Let me open the program again and the target matrix. Okay. This is our target matrix. So for a particular train feature, I have made some target matrix. As you can see, this target matrix also containing 650 rows and the 26 number of columns. It means if it encounter, if our features encounter like this, okay, 100 features like this, it represent a target sequence like this. Okay. And in each target sequence, I am having 26, 25 number of ones at the very beginning and rest of the zeros. And zeros goes till 26, 6 till 650. So that means what I am having as in that's a difference between traditional support vector machine and the deep learning. In support vector machine, what I do, I make the labeling directly. Like I label this thing at 109th column 1, at 109, yeah, at here 111, thereafter 222, it belongs from class 2, thereafter class 3. But in case of deep learning, what I require to do, I require to create such type of table every time for making the target vector. Okay, 1 1 1 1 1 here. Okay, it will goes to zeros till 25. Okay, at from the 26 start one. Okay, that means here the second alphabet start, it will go similar like 50. From 51 it will do like this, and it will goes up to 75. From 75 it will goes up 1 1 and further. Okay, so here I created the target matrix corresponding to our previous data set. This is our data set, I already told you. So after creating the data set, I start the train first. In deep learning, what I required the input feature, and I created the with the help of autoencoder, I created the auto encoded features. Okay, here I taken only the input vector x. Okay, input matrix. Okay, and with the help of input matrix, I again created the feature. So let me show you this thing. Yeah, I just copy this thing, I just paste it here. and press enter. Here the first phase of training is start. Okay, it goes up to the 400 iteration. Okay, the validation check the performance as along with it has 108 input layer, the autoencoder layer, the decoder layer, and the output matrix, and the performance can be shown with the help of plot of regression plot. Okay, and the best training performance, as you can see, there's a straight line we are obtaining. That means okay, at this time we don't have any target matrix. Okay, we always get a straight line like this with 400 epochs. Epochs represent the number of iteration in this case. Okay, and we what we obtain at the end, we obtain the feature one matrix like this. So these are the previous feature I had shown you as input. Okay, and what neural network did with these type of features, it encode these features into some random sequence. Okay, so it is more relevant than the previous one. What I do again, I again use encoder second time with different number of hidden layer, and I created the feature 2 matrix. So that's the second type of training. Only 100 iteration, 116 input layer, 116 output layer. Okay, the performance of regression plot now it goes down because previous feature, the features we had obtained previously. Okay, I just said okay is was going straight, and with those features are more relevant. So this time the training will yield more positive result. This downfall on the curve, this downfall on the curve, this downfall on the curve shows the better training. If curve goes upward, that means training performance is down. If curve goes straight, that means training nothing is happening at the time of training. Only the feature encoding being performed. Okay, so I'm just going to show you this thing with more number of iteration again. Okay, it's this time I'm taking 500 iteration autoencoder, and the features this time I'm going to take is feature 2. I had obtained these feature 2 at here. So the feature 2, and this thing I am going to say the features 3. Let's see if what happened with features 2, whether it will show the relevant feature or something else. So with the 500 iteration, the performance is going much better this time. And let's see what happened with performance curve. You can see the curvature start from this point, and it's almost achieved the optimum performance before completing the 500 iteration. That's how deep learning do. If I train multiple times, that means performance goes up, 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 and up. Okay, so here I did some specific change on my program, and I'm going to train my rest of the program with feature 3. And let me show you my concatenated deep learning neural network. Here this time, at the very first time, I give the target matrix at this place. Okay, the feature 3 and the target matrix. And what I obtain here? Okay, a better performance. Here the 58 input layer, 26 output layer. Okay, at 400 iteration, I obtain the soft network. And let me show you the soft network. WEIVW, soft net. Okay, this is our soft network. Okay, so what I did finally, I add all these network, and let's see how it look like. Mm, I got an error. Oh, I just run the whole program again because I need to add some layers here. Okay, it looks good. No, 400. So I'm going to run, and Let's see what how deep net look like. So I had already explained each of the layers, so let the process goes for till the end. Okay, so this thing looks like a deep network. 108 input layer, 26 output layer, that means 26 alphabet. It how many times it get trained, it encode the feature twice, and the training will done with the help of softmax. And this is our deep neural network look likes and will give output layer. Now let's see how, yeah, you must have seen the deep learn the structure of deep network. Let me see whether what is the performance in terms of confusion matrix. Okay, so with the help of deepnet, what I obtained the deepnet here. So I name this network as deepnet. Okay. Okay, so what I required the testing performance of deep network. Okay, so what I do use the input so that I can be obtain the performance of it. So this is how it's look like. What I get, I must fed these features to somewhere else. QAQ, I just fed these things, and for getting the better performance of the deep net, what I am doing, I'm going round off the features. So I stored these features as QOQ. So let me make the round of QAQ in QWE ROUND round. QAQ. Okay, so let's see how what is the performance in terms of confusion metric. This is a target, the inputs. Let's see. Okay, the target and output both have different values. The QWE, the inputs. Sorry, 13. So this is our confusion matrix look likes. Okay, it's concatenated way. Okay, if I zoom, there's a zoom available. Property editor, zoom, there is zoom. Okay, no, let it be. So let me show you the zoom part of it. Minimize this thing. Oh yeah. Okay, let it be. Shift plus chodo. Okay, yeah, this is look like, and here you can see the zeros and diagonal matrix shows the good performance at the last end. You can see if wish you would be able to see, though there's a gauge pitch available. Okay, so that's a performance of 99.8 percent accuracy has been shown with the help of deep neural network. Okay, and if I don't show the roundup value, if I show you the QAQ value, let's see how much performance we had obtained. It's also show the confusion matrix, but the performance is all, yeah, its performance is similar. Okay, I'm getting call. Just hold on a second, my friends. Let's see. Okay, so okay, friends. I hope this time I've shown some valuable information to you how deep learning it can be performed and what is the difference. So I'm again run an application, going to run it, and will show you the application of this thing. Testing. You just obtain a test image. Don't open your book. Open your mind and watch my video. Okay. Okay. Train your mind with deep learning, multiple training. Okay, and just right after training the encoded network, and let's see how many text we can be extracted with the help of this. The next. Okay. Open your book. DONTOPEYOURBOOK. Open your book. Don't open your book. Open your mind. So it's working good. It's working good. Okay. So with the help of deep learning, you can just write everything on your own. I hope I've give you valuable information this time again. Uh, Thanks for watching my video and must share with your friends. Okay. Lastly, I'm going to tell you again. This is Ajay Jatav. You can call me for research query problems or for training and that for training in deep learning, Python training, whatsoever you want to learn. Okay. I belong from an organization who develops thousands of algorithms already for future upcoming technologies. Okay. And thanks, my friends, and goodbye. Love you all. I'm ending up this time.